my colleagues asked me what I was doing as I was coming in to tape today, and I said, I'm taping a course on linear algebra. She said, exactly what's linear algebra? And I said, well, you know, we did a little bit of matrices back in trig. It picks up with matrices and continues. And she said, well, you know, I really didn't like matrices that much. Well, if you agree with my colleague, not a math teacher by the way, if you agree with my colleague, then you're going to be in for a hard time in the course. The course deals with matrices over and over and over. In the last unit, we used matrices to solve systems of equations. In this unit, we're going to consider the operations on matrices, adding, subtracting, multiplying matrices, doing scalar multiplication. I'll end today's tape by giving you an application. To multiply a matrix by a scalar, multiply every element of the matrix by the scalar. Now, a scalar is just a real number. So to multiply a matrix by a real number, multiply every element of the matrix by the real number. As an example, let's multiply the matrix 2, 5, negative 4, 1, 4, 12, 2, 0, negative 6 by the scalar 3. I simply multiply every element in the matrix by the scalar. 3 times 2 is 6. 3 times 5 is 15. 3 times negative 4 is negative 12. 3 times 1 is 3. 3 times 4 is 12. 3 times 12 is 36. 3 times 2 is 6. 3 times 0 is 0. 3 times negative 6 is a negative 18. One can add and subtract matrices having the same dimensions. So if you have two matrices that have the same dimensions, then you can add and subtract them. One simply adds or subtracts corresponding elements. So once you verify that you have the same dimension, then to add or subtract the matrices, you simply add or subtract corresponding elements. Let's look at an example. Here we are subtracting. Now let's verify that we have the same dimensions first. Here we have 2 rows and 3 columns, so this is a 2 by 3. Here I have 2 rows and 3 columns, 2 by 3. So these are the same dimension, so therefore I can proceed with the subtraction. To subtract, I simply subtract corresponding components or elements. 1 subtract 3 is negative 2. 4 subtract 5 is negative 1. 5 subtract 0 is 0. 2 subtract a negative 6 is 8. Negative 2 subtract 2 is negative 4. 4 subtract 12 is negative 8. one can multiply a M by N matrix by an N by P matrix. The product will be a M by P matrix. Notice that to multiply, the columns of the first the number of columns of the first matrix must match the number of rows of the second matrix. So if you put down here, we must match. If they do not match, then you cannot perform the multiplication. Now once you verify that you can do the multiplication, then the outside will give you the dimensions of the answer. So the answer would be M by P. So the number of columns on matrix 1 must match the number of rows on matrix 2 for you to be able to multiply. If you can multiply, then the dimensions of the answer will be the number of rows of matrix 1 by the number of columns by matrix 2. I'm going to give you the rule to follow for multiplying. Simply copy the rule down now, then I'm going to give an example. Once I do the example, you come back and look at the rule to see if you can follow it. So we're multiplying matrix A by matrix B to get matrix C. The Cij element, so this is the element in row I, column J of matrix C, and the product C is calculated as follows. A, I row, first column, times B, first row, J's column. See how the I's and J's work. Plus A, I2, B, 2J, plus A, I3, B, 3J, plus all the way to A, I-N, B, NJ. I'll give you a moment to get this copied down. Then I'll actually illustrate it with an example. Example, let's multiply the matrix 3, negative 4, 5, 1, 2, 6 by the matrix 2, negative 1, 6, 3, 5, negative 2. Or if I 2, 3, negative 1, 5, 6, negative 2 if I read the rows. Well, first of all, let's verify that we can do it. We have a 2 by 3 matrix. 2 rows, 3 columns. And I'm multiplying that by a 3 by 2 matrix. 3 rows, 2 columns. Notice that we do have a match, so therefore it's possible to do the multiplication. the answer will be a 2 by 2 matrix. So knowing my answer is going to be 2 by 2, I'm going ahead and create a place for it. 1, 2, that's one row with 2 columns. 2 rows with 2 columns. So it's going to be a 2 by 2 matrix. Now this will be C11. To get C11, I multiply the elements in row 1 by the elements in column 1. So we use, for C11, I use row 1 with column 1. And I simply multiply in the corresponding parts. 3 times 2 is 6. Negative 4 times negative 1 is 4. 5 times 6 is 30. Again, 3 times 2, negative 4 times negative 1, 5 times 6. And I used row 1, column 1 for entry 1, 1. Now this is entry 1, 2. So for entry 1, 2, C, row 1, column 2, so this will be C1, 2, I use row 1, column 2. So I'll still use row 1, but I'm going to slide over and use column 2. So for this one, it's row 1 with column 2. 3 times 3 is 9. Negative 4 times 5 is negative 20. 5 times negative 2 is negative 10. Again, 3 times 3, negative 4 times 5, 5 times negative 2. This is entry 2, 1, position 2, 1. So it means I use row 2 with column 1. 2, 1. Row 2, column 1. Multiplying, 1 times 2, 2 times the negative 1, 6 times 6. 2 times 1 is 2, 2 times negative 1 is negative 2, 6 times 6 is 36. Here we have 2, 2. So row 2, column 2. 1 times 3 is 3. 2 times 5 is 10. 6 times negative 2 is negative 12. Simply finish adding to get my answer. 6 and 4 is 10. 30 and 10 is 40. 9 minus 20 is negative 11. Minus 10 is negative 19. 2 minus 2 is 0. 0 plus 36 is 36. 3 plus 10 is 13. 13 minus 12 is 1. So there's your answer. Multiply. Two, negative 4, 1, 6, negative 2, 8, by 1, 4, 6, negative 3. Now the first step is to see if we can do it. This is a 2 by 3 matrix. Here I have a 2 by 2. 2 rows, 3 columns. 2 rows, 2 columns. No match. Cannot be done. But if I have something like 1, 2, 4, one, negative 4, 6, 2, 0, 4, 0, 0, 1. This one can be multiplied. I have a 1 by 3, 1 row, 3 columns. Here I have a 3 by 3, 3 rows, 3 columns. It matches. My answer will be a 1 by 3. So it would be 1 matrix and 1 row with 3 columns. So I use row 1 with column 1 to get 1, 1. 1 times 1 is 1 plus 4 plus 0. 1 times 1 is 1, 2 times 2 is 4, 4 times 0 is 0. Now this is row 1, column 2, so I use row 1 with column 2. 1 times negative 4 is negative 4, plus 2 times 0 is 0, 4 times 0 is 0. Row 1 by column 3, 1 times 6 is 6, plus 2 times 4 is 8, plus 4 times 1 is 4. So I have 5, negative 4, 18. 8 and 6 is 14, 14 and 4 is 18. Now I'm ready to give you the application that I talked about. A company owns 3 factories, and each factory produces 2 grades of shoes. Matrix S shows the number of each grade produced by each factory. So matrix S shows the number of shoes of each grade produced by each factory. Entry Sij shows the number of units of grade J produced by factory I. So this shows the number of units of grade J produced by factory I. Matrix P shows the price of the 2 grades of shoes. Factory 1 produced 345 units of grade 1 shoes. Factory 2 produced Factory 1 produced 546 units of grade 2. So Factory 1, 345 units of grade 1, 546 units of grade 2. Factory 2, 128 units of grade 1, 137 units of grade 2. Factory 3, 247 units of grade 1, 543 units of grade 2. So S tells me the number of units of shoes produced by each of the factories and for each grade. So Factory 1, Factory 2, Factory 3, grade 1, grade 2. P, your price matrix, tells me the price for each grade. The grade 1 shoes were $65.49 each. The grade 2 shoes were $129.95 each. One can multiply S by P, because notice S is 1, 2, 3 rows, 2 columns. P is 2 rows, 1 column. So we can multiply S by P, because we do have the match. So we have 3 rows telling me the factory in matrix 1, 2 columns telling me the grade, 2 columns giving me the grade in matrix, the price matrix, 2 rows with the grade, and 1 column which is the price per grade. So the answer will be a 3 by 1 matrix, which gives me the total revenue for each factory, the total price for each factory. So the result will be a 3 by 1 matrix that gives the revenue generated by each factory. 3 factories, price which relates to money. So 3 factories, the money produced by each. We will use derive to do the multiplication. To use derive, you go to author, and then you author a matrix. It's going to ask you the dimensions, so you have to click to enter the dimensions of the matrix, and then you will enter it. So to enter matrix, you enter the element, then you press tab, enter element, and so forth. But the key is, after you enter an element, press tab. Now when you do this on derive, you need to actually go into the lab and do it. You will notice that when you type matrix, it gives you the array to fill in. So we do matrix with dimensions, it will give you an array that looks something like this for 2 by 3. And you'll have your cursor here. So you put in your element, hit tab, and the cursor moves here. Enter, hit tab, cursor moves over. Put in your element, tab, moves here, and so forth. Then when you get through, you click OK, and your matrix will show up in the on the screen. So this is how you enter the matrix. So you need to author or enter both matrices. S and P. In matrix S and matrix P. Now when you get through entering matrix S and P, it's going to look something like so. This is matrix S, and the way I did that, I went to author, and I said author a matrix, and I said I want a 3 by 2, and I put 345, tab, 546, tab, 128, tab, 137, tab, 247, tab, 543, and clicked OK. Then I went back to author a matrix, and it asked me for the dimensions. So this time I said I have a 2 by 1. 2 rows, 1 column. I put 65.49, tab, 129.95, and clicked OK. And it displayed the 2 matrices. This is your price matrix here. Now to get it to do the multiplication, I go back to author, and I put author expression. And then I put number 1 for expression 1, which was matrix S. Use the period. Derive uses the period to indicate matrix multiplication, and then put in number 2. So I'm going to multiply matrix 1 by matrix 2. And then I click OK, and derive gives me matrix 1 times matrix 2. Now I simply go to simplify, basic, and derive gives me my 3 by 1 answer. But since we're talking about dollars and cents, I really would rather have a decimal. So I tell it to approximate 2 decimal places. And we see that the total revenue generated by plant 1 is 9.3 times 10 to the 4th dollars. And if I want to change that into decimal, it would be 93000. The decimal exponent 4 tells me to move my decimal over 4 places, so it was here. So I move it 1, 2, 3, 4. So plant A generated $93,000 revenue. Plant B, or the second plant, would be $26,000, and the third plant is $86,000.